Hello everyone, we're starting a free open lecture in our Discord channel. All our lectures are held daily, without breaks. If you're a viewer and want to ask questions and get answers in an online format, then join our lectures. You can find the link to Discord in our Telegram channel. To find out the time of the lecture, join our Telegram channel and Discord. Standard, 1 second, 256 megabytes, problem 800. So, what do we have? We have a board sized n by m, and we're standing at point x1 or x1 and want to get to point x2 or x2. Well, it's not us, but it doesn't matter. Someone is trying to get there. So what do we need to do? You need to put up some walls, roughly speaking, block some cells so that the person cannot get from x1, y1 to x2, y2. So here we have a board, each of the dimensions up to 10 and 9. And it is guaranteed that they are not adjacent. They do not have a common side. That is, they cannot stand next to each other. That means we can always block them. We need to find the minimum number of blocks that we can place. But we want the minimum number, and that's exactly what we want to find out. So here the answer is 4. This is exactly the drawn test case in the first example. So we place 4 walls. Now let's approach this very logically and easily. How many walls do we need at most? The size goes up to 10 to the power of 9 for each dimension. Well, actually, that's already the answer, the number of walls. Well, actually, the number of walls is not exactly equal to the number of points from which you can reach the endpoint. It's both yes and no, because there can actually be fewer walls than the number of points from which you can reach the endpoint. But yes, it's close to that. What's the deal? In fact, we will never have a case where we need more than 4 walls. Why? It's really very simple. So we have this infinite, extremely huge board. It doesn't matter. We have some specific starting point on this board and an endpoint. Yeah, we just surround that particular point on all 4 sides, and then it can't be reached. But the only thing is that in the case I've drawn, 4 would be the wrong answer. Why? Because actually, you see, we can do it in 3. If instead, we block the player themselves, the little guy, the player, it doesn't really matter. So yeah, we just choose the advantageous one to block, and then we just give the answer. It's such a simple problem, it has nothing to do with graphs, except for the tag for some reason. There are even streams, although they're not clear here, but yeah, the problem is just, well, it's really simple. For the test cases, we just read them and insert them. It will get better from here. 2 seconds, 256 megabytes. Yes, 100 Ks, each of the characters, of which 1, 2, or 3. We must choose the shortest continuous substring of S in which each of the 3 characters occurs at least once. So basically, we need to output the length of this substring. The number of input sets is up to 20,000, but the total length of all strings does not exceed 200,000. In our case, this is the only limitation that concerns us. Well, for each set of test data that we output, this is one single number, the length of the shortest substring of S that will contain characters of all 3 types. If such a substring doesn't exist, we output 0. So 7 is the number of test cases, but as I said, in this situation, it doesn't really concern us much, because the complexity is limited here. We can't do it in quadratic time, obviously, because we won't have enough time. We need to choose something shorter, and here are our options. Yes, we need to do this with 2 pointers, right? So, in the first case, it's clear we have the correct answer, and in the second, yes, we need to do this with 2 pointers, right? So in the first case, it's clear we have the correct answer. In the second one, here it is in the third one. Let's highlight it in the fourth one. Let's highlight it. In the fifth one, it's not there because we don't have a trio. In the sixth one too, 7th quartet. So, how are we going to do this with 2 pointers? Got it. One of them will be moving, the other. So the question is, what will the other one do? Because it can move towards the other side. It can move behind the first pointer. That's how we're going to use it. The first one moves from left to right, always, that's for sure. With the first pointer, this is how we're going to use it. The first one moves from left to right, always, that's for sure. This is what direction the second one is moving. While the training will be in the segment, this is, well, overall. By the way, this is also one of the options for solving it. Actually, it's pretty simple too. We're going to move the second pointer from left to right as well, and we'll be going from left to right, adding to our counters the number of 1s, 2s, and 3s. I set up a map for this, but you could have used anything really. You could have just added simple variables, too. It's not that important, and it's just readable. First, we put 1 into the first position, then in the second position we put 1, 2, 3, 4. We add another 1 to the first position, making it 2, and it will jump to the third position where we put 1. It's clear that we'll find it, but the length will be too big. So as long as the value from the second pointer is greater than 1, we'll move our left pointer. The second one can be either left or right, but it's important to move to the right. Both started from here, but the right one stopped here, and we start moving. We have 1 here and 2, so we subtract and move left. From 2, we can see we have 4, so we'll move, and we'll actually move to the last 2. It will turn out to be 3. In fact, when we get the answer 3, we can already finish. But it's not that important. Our complexity allows us not to stop, so after we find this, we'll look for something smaller. But we obviously won't find anything less than 3. The same will actually happen in all other cases. If we go through and find nothing, then it's clear we have 0. How do we do that? The easiest thing for us to do is to create a variable for the answer and set it to a large number, like over $200,000, because that's the maximum length of the string. Well, I just took max so as not to suffer. And just every time I received an answer, we compared, took the answer, equated the minimum of the answer, and our current result in a systematic manner. From the answer to the code of the current result, if at the end we had the answer equal to int max, then we input 0, otherwise we input the answer. There's probably nothing too interesting here, so here's the code, carefully and thoroughly detailed in our process. As we proceeded, in this context, as a result, ultimately, in conclusion, in essence, in summary, in the end.
Want to become a great programmer? Subscribe to our Telegram channel.